Aloha kakayaga kako.
That was so bad.
Some of you got high scores on this. Where's yours, Mark?
Oh my god.
But we need to go over this entire thing because
Yeah.
you cannot just bank on the rest of the nation being stupid.
That's what we did for physics.
True.
Hey, come on, we're BC. You're expected to get high scores. Yes, it's curved.
Oh. Wait, did you curve for this one?
Yeah, I based it on the curve. Okay, here we go. Number 1. Now, I'm not going to go over all the problems so we can save time here. So, no, we're not. This is not AB, right? Yeah, the hardest one is D.
Is that every
Call
Now,
out.
did everybody get the reasoning correct for part B?
Yeah.
Using a left Riemann sum, is it an over or an underestimate?
Over.
Over. Okay, what's the reason? Because
R.
R is decreasing. That's all you have to say. It has nothing to do with concavity. Did everybody get the point for that?
Yeah.
The reason for part B.
Oh wow.
Okay, and then let's just do D. Now D, I gotta admit, it's pretty tough, but it's really not that tough. Is there a time when the rate at which the water is being pumped into the tank, which is W of T, equal to the rate at which water is removed from the tank, which is R of T?
To solve the equation, move all the things on one side.
Did you guys think of that yourself? Or did you guys have help?
I had hope.
I told you guys to do this on your own, otherwise that's not a valid score. Pick up a whole point for that. You're down from a 5 to a 4.
One was like -1. Okay, never mind.
Yeah, 5 minus 1 is 4.
I was talking about like the 40, like 5.
Oh, now you start to listen. Okay, so you can think of this as the net rate, yeah? So basically, is there a time when the net rate is equal to 0?
Yes.
Yeah, but you gotta figure out how to do it, you gotta show it. Somewhere between 0 and 8, so when you see that, you're probably thinking, oh, gotta be the intermediate value theorem here, right?
Yeah.
So what you do is you plug in 0 here. What is the net rate at 0? Now, you guys, some of you plugged it in, what did you guys get? Just tell me if you came out with a positive or a negative number. You
Positive.
came out to a positive number, and then you plug in 8, so the net rate at 8 is what? Came out to a negative number. So, to go from that positive to negative, does it have to hit 0 somewhere in between?
Yes, sir.
Yes, because the function is continuous, because it says right here, both functions are
Continue.
differentiable, which means it's continuous, right? So, the intermediate value theorem guarantees it. Part.
For the explanation, do you have to put yes because R and W is continuous, or can
Yeah.
alright, so we have
Yeah.
to say
Since both functions are continuous, the intermediate value theorem guarantees it.
so you can
So
just
this
say
is how the points were distributed. They said if you just consider W minus R, that's 1 point. So if you just like wrote that down on your paper, you got 1 point.
really?
And then, yeah.
Like I thought of that. I was
But
like,
then you gotta write it down. We cannot, when we grade papers, we cannot predict what you're thinking. It's gotta be written down on the paper. So yeah, 1D is tough, so that's why we have to get 1, A, B, and C, because those are the doable ones, right?
yeah.
Okay, number 2. Aha! Okay, I'll draw the graph over here. This is the graph of the bottom of Wonga Punga Dunga. And they told you that x dot is equal to t squared plus sine of 3t squared. And the t equals 0, the position is at the point 5, 1. And already you know, since they give you that, you gotta use code red somewhere in here, right?
Yes, sir.
Okay, you tell me what we had problems with. I'll tell you what we had problems with. D.
well, yeah.
A?
Why is it minus 1/2 for the y value?
Because
Are
the
you
graph is
serious?
and t equals 3, the y is at -1.
Because at time, the graph of y, so this is the graph of y, so they want at t equals 0. Wait, what are you talking about? It says find the position of the particle when t is 3. So when t is 3, wait, 1, 2, 3, 4, right there, here's 3. What
But
is the y value right
You
there?
don't have to use the original, like, the original.
No,
like,
because this is the y equation. This is not dy dt, this is y. Because look, it says y. So that means what is the y value when t is 3? It'll be negative half.
Oh.
You don't have to do an
So
integral for that.
why did they even give you the original position of y then?
Because that's what they wanted to do in their problem.
This one's
So one of them they gave you dx dt, but the other one they actually gave you y, so you gotta be careful. So did we get everything else except d? Do we need to do d?
Yeah.
Yes, okay. How do you find the total distance traveled from 0 to 2? Well, that's pretty easy. Wait, we're doing d. What is the total distance traveled? The integral from 0 to 2 of the square root of dx dt quantity squared plus dy dt quantity squared dt, right? But we have a problem because y, look at y,
It's
from
not
0 to 2, it's a
differentiable.
piecewise function, so we're gonna have to make two separate integrals.
Julio.
Okay, so one integral is going to go from 0 to 1, square root of,
Mr. Park,
Mr. Park,
That's
you
not a
just
one.
said it's two.
but I said a 1, so when I say a 1, you write down a 1.
how about you write down the one?
dx dt, but they gave you dx dt, so you can just actually just write dx dt because it's given in the problem, plus dy dt squared dt. Now, from 0 to 1, if this is the graph of y, what is dy dt? That would be the slope of the graph, which is negative 2. And then you have to do another integral from 1 to 2 because of the piecewise function of the square root of dx dt squared plus dy dt squared dt. And then if this is the graph of y, dy dt is the slope of the graph right there, which of course is 0. And then punch it in on your calculator. I forget what the answer was. Who got it correct?
4.250.
4.250. 3 whatever.
Wait, do you have to punch it in or can you just leave it as like?
No, you gotta punch
Oh,
it
yeah.
in. Integrals gotta be punched in, gotta be computed.
Wait, why do you have the square? Oh no,
Because-
just kidding, I got it.
Because y is a piecewise function, yeah? That was, I guess, the trick of that problem. Okay, what about number 3? No, we have to go over this.
B.
You know why? Because some people are not considering the endpoints. And that would be very bad.
Is this why you got mad at me?
That endpoint.
What did you
did the
do?
endpoints of this one.
No, a lot of people that.
Yeah.
Oh.
I got marked on
Okay,
the
C and D.
Yeah,
I never do that, I'm so proud of myself.
Okay, number 3, I guess I have to draw this graph here. So, 2, 4, 6,
Who do we,
8, 10, 12.
Yeah.
Yes?
No, no. We're singing 5466. Who do you appreciate?
3 of the problems are exactly the same as AB too.
Not.
Okay, so here we go. This is the graph of f. G of x is equal to the integral from 2x of f of t dt. So you already know you're going to use the fundamental theorem of calculus, right? Part 1 before we even start this problem. Anyway, it says find the absolute minimum and the absolute maximum value of g. Now, when they say value, they want the y coordinates now. From -4 to 12, including the endpoints. So that means if you do not check the endpoints, you lose half the points already. You have to consider the endpoints. So what's the procedure for finding maximum and minimum points? You take the derivative and you make a number line. Some of you don't even have number lines. How do I take the derivative of this? Let me call on people. Kurumara, what's the derivative of g? Times? Okay, just making sure. So now we make a number line. Woo! Well, if this is the graph of f, it's also the graph of g prime. So just make a number line for this graph that's written here. Where does it touch the x-axis? -2, 2, 6, 10. Below, above, above, below, below. G is decreasing, G is increasing, G is increasing, G is decreasing, G is decreasing. So you can clearly see now, whenever they ask you to find absolute maximums and minimums, they want you to like gather all the maximums and compare them, and you pick the one that's the biggest. So where are there? Yes.
Do we actually have to like put a key?
Yes.
Really? Why can't we just do that?
Wait, that's
Because what does this mean? I don't know what that means.
Yeah, but then you don't have to put that on the actual paper, right? Like you could just leave it like this without doing that.
Okay, what to do. I told you what you're
No,
supposed to do. If
I'm
you're not gonna
asking,
listen,
I'm
no, you need to write this.
But with the key?
If you don't have a key, then you're gonna write decreasing. Is that what you really wanna do?
No.
Okay then, follow.
Did you say we don't even need a number line? So if we don't even need the number line, then if we have the number line, then we have.
Okay, in reality, you probably do not need the number line.
Right.
Okay? But I'm just trying to make sure we get the points. You know what I'm talking about?
Okay.
Yeah.
Okay, did you have the justification then?
Yeah.
Okay, let me ask you this then, follow. Is there a max, min, or neither at x equal negative 2?
Min.
Why?
Because g of prime changes, g prime changes from negative to positive.
Is there a max, min, or neither at x equal 2?
Neither.
Why? But then you're looking at my number line, but you don't have a number line. Okay, so, right? So you said neither, why?
I'm saying that if we did have the writing on it, then it wouldn't be taking off points if we don't even need the number line itself.
Yeah, but you have to have the justification that that's a minimum point.
Oh, so I see, so if we
So
have
you
that,
gotta say,
that's right.
there's a minimum, there's a relative minimum at x equal negative 2 because g prime changes from minus to plus. And there's also a relative minimum at x equal 12 because it's an endpoint. Did you say that on your paper?
I didn't
No
say-
further questions, Your Honor. The defense rests. Davis?
If I wrote a key for this problem and say I want to do a number line on the next problem, do I have to rewrite the key?
No.
Okay.
As long as, okay, when you take the free response, it's gonna be on 2 pages like this. First page, second page. So it's gonna be like A, B, C, D. It's gonna be like on there, it's not like you're gonna have to flip. So when we grade, they tell us that if it's written somewhere on these 2 pages, you have to take it.
Oh,
So even if you have like something written over here for part A, we gotta give you credit for that.
Yes!
No, for real. That's what they tell us. Anywhere on those 2 pages, we gotta grade.
It's funny.
Okay, so can we get on with this problem?
After every single one.
What?
They give space after everything.
Yeah. You get half a page, at least half a page for each.
Just write the answer backwards,
What?
upside down.
What's upside down?
Just write the answer upside down.
Make a one.
You guys are killing me. So what are our, so we have relative maximums at what values? Where are the relative maximums? At this endpoint, which is -4, and at 6. So what we need to do is we need to compute g of -4 and g of 6. This is what they want to see. They want to see you computing both of these and picking the bigger of the 2. That's what they want to see on your paper. So, how do you compute g of -4? You use this. So, that would be the integral from 2 to -4 of f of t dt. But then, stay the wrong way, so we gotta switch them. Like that. And then, if this is the graph of f, the integral from -4 to 2 would be this area here. And I believe, oh, what am I doing? I believe each one of these triangles is 4 square units, right?
Yes.
Did you guys compute it? So this will cancel that, and so you get 4. That's what I got. Okay, what about g of 6? You plug it in, you get the integral from 2 to 6 of f
To
of t
make it
dt.
negative,
What?
yeah.
you got the negative sign.
Yeah, it's right there. The integral from 2 to 6, I better write this in so I don't make any more mistakes, would be this area right there, but it's above the x-axis, so that's 8. So what's bigger, 8 or -4? Remember, you don't have a calculator. What?
Yes.
It's 8.
8.
So the absolute maximum value, g of 6 is equal to 8. Actually, they want the y coordinate, but I think if you just put g of 6 equals 8, that'll be good, more complete, yeah? Now, what about the mins? Well, we have relative minimums at where? Right there, and right here at this endpoint. So they want to see you comparing g of -2 and g of 12. Now, what happens when you plug in -2? You get the integral from 2 to -2 of f of t dt, but stay the wrong way, so you negated -2 to 2 of f of t dt, and that comes out to -2 to 2. It's right there. 8, but -8. Okay, g of 12, integral from 2 to 12 of f of t dt
Or
is from 2 to 12. You got all of these areas, but then some of them are negative. So this cancels that, so you just get base negative 4, right?
no, but
What? Okay, so what's smaller, negative 8 or negative 4?
Negative.
Negative 8 is smaller, so the absolute minimum value is g of negative 2, which is negative 8. Boom. That's what they want to see, comparing all the maximums and the minimums. Wamer.
Is the number line wrong if you don't put 2 and it doesn't change?
If you don't put what?
2 and
Kind of, because it's 0 right there, right?
10. Yeah.
What do you put on your number? What are critical points?
0.
When it's 0 or doesn't exist, right? So you should have 2 and 6 on the number.
Off.
Okay, like I said, no, because, okay, I'll just say yes.
I didn't do that.
No, because I don't want to say, because you know what follow's going to do, right? Just don't do it, you know?
Yeah. But so I didn't.
Okay. Okay, number 4. Ooh,
Hey.
I see a L'Hopital's rule there.
What is this STT? Show don't tell.
Lopita.
That's my boy.
Show don't tell.
Wait, SD,
second derivative test.
oh, second derivative. STT. You mean STD?
No, that's what you mean.
Oh, what about D? Oh, I erased the bloody crap.
We don't need the graph. We don't need the graph. We
No,
don't need the
you
graph.
do.
We have it on the paper.
No, but it depends on the graph.
We have the paper.
I don't care.
Here. Here's the
Okay, I'm
graph.
gonna watch it.
That's what I said.
2, 4, 6, 8, 10, 12. 2, 4, 6, 8. Why is that a 10? That's what happens when you rush. I'm trying to stop. Why are you talking about STDs?
You.
We're not talking about
Dun, dun, dun.
Okay. this is the crap. Okay, between negative 4 and 12 inclusive, because some of you didn't. I don't know. Find all intervals for g of x is less than or equal to 0. Now I gotta write this down. G of x is equal to the integral of 2x of f of t. So they want to know when is g of x either 0 or negative. Now, we already computed 4 values of g here, right? We can actually use this to help find our answer. In fact, I think if you just compute the value of g at every key point here, you can answer the question. So why don't we make a chart? Let's make a chart. X, G. Negative 4, negative 2, 0, 2, 4, 6, 8, 10, 12. No, some of you can just see it already, but I'm just trying to I'm trying to okay, now we already know these. Look, let's put the ones we know. Negative 4. What is 6? 8. What is negative 2? Negative 8. And what is 12? Negative 4. Now, can we fill in some of these other ones here? Like, what would happen if I plug in 2 for x? What happens when I plug in 2 there? You get 0. What would happen if I plug in 0? Can you see what that is? From 0 to 2, that's 4, but then
Negative 4.
negative 4. What about at 4? What if this is a 4? From 2 to 4?
4.
4. What about 8? 2 to 8?
4.
4. And then 10. 2 to 10, 0. Okay, I think we can answer the question already. So where is g of x less than or equal to 0? From negative 4 to 2. And then from 10 to 12. Where did you put your test?
I do that.
And it's all done?
Yeah.
It's not done till I correct. So you might have to make a return. Okay. And then I don't know if it was A, B, or B, C because they got the same problem. Somebody did not put a U there, and they didn't put a comma like I told them to. They put the word and.
So is that
Was that you?
No, that was me.
Is that marked off?
Well,
I
and
put
means
commas.
intersection, and at the intersection of these two is no solution. So you're saying no solution if you write the word and.
I put a comma.
Yeah, I always put commas because you told us that you can't put
Okay,
commas.
very good. That's what I'm talking about.
That's like cheating.
If you don't know what symbol should go there, just put a
The
comma.
comma is cheating.
You put the other notation.
Well, this is the correct notation. That's
You
correct.
put like
What is
negative
SDC?
4.
Oh, yeah, yeah. no, this is, oh, you mean
Yeah.
-4 is less than or equal to x is less than or equal to 2, or 10 is less than or equal to x is less than or equal to 12.
Yeah,
That.
that's right.
Yeah, so this is correct notation, that's correct. But if you don't know, just put a comma. Do not use the word and.
So then we correct it.
Next problem.
No, I was looking at your hood.
Next problem.
What's wrong with this hood?
You're not supposed to be wearing
I'll take
hoods.
it up when we get to the next problem.
What is this, a protest or something?
So,
Okay, now can I erase this?
Yeah.
so if you get
Woo!
Number 5.
Workers will work us.
40, yeah.
Here, I want to tell you a story before we start. Number
Can
4.
we go get lunch?
I got some. I didn't know that.
Hey, there's only 15 minutes in class. We're in trouble.
No, there's
Wait,
10.
just- just-
Actually,
Oh, that's only 10. Okay, no story.
No, what's the story?
You know, in AB,
Got this correct.
they did so terrible, and then they did so terrible on the final exam, and then get so many people getting 5s on this, and then it looks, we have to have a second final exam.
That's not even a story.
I'm telling you a story. They're gonna have this exact same test again on Friday. You have to prove to
oh
me
yeah,
that
that's
you do it
what
on your
someone
own.
told me.
It's so mean.
It's because we did well in the homework,
I
because they
wanna-
had Googled everything.
Okay, find the second derivative. Do we have to do part A?
No.
Yes, we do. 2x minus 1/2 y prime, but what is y prime equal to? X squared minus 1/2 y, should we just leave it like that?
Yeah,
Okay, good. Okay, B. Are we doing B?
yes.
No.
The particular does the graph, come on, you know this is the second derivative test. At the point -2 comma 8, is that the right point? What is the value of the first derivative? What happens when I plug in -2 for x and 8 for y? -2 squared minus 1/2 8, that comes out to 0. Oh, so if the first derivative is 0, that's a possible max or min. We need to look at the second derivative now. So if I plug it in, you get 2 times -2 minus 1/2. Well, we already computed the value of the first derivative, which was 0, so we get -4. Oh, if the second derivative is -4 and the first derivative is 0, that means there's a horizontal tangent and the graph is concave down. That means we have a relative maximum there. And what is the reason that I want follow?
Second derivative test.
Thank you. The second derivative test. That's why I wrote STE.
You wrote
No.
STE.
STE. The second derivative test. They want you to refer to theorems, and that's
Oh, so
the
you have to,
theorem.
you have to
Now,
write it
if
down.
you want to, you could just say, because the first derivative is 0 and the second derivative is negative at this point.
Yeah. Like,
But come on, it's just like, when we come across the intermediate value theorem, don't we just say intermediate value theorem guaranteed?
Wait, I can literally just say
Second derivative test.
Um,
That's a known theorem.
because the SDT proves guarantees it.
No! This is a relative maximum because of the second derivative test. And don't you dare write STE on it.
Just for that, I'm gonna put it.
Okay, what about part C? Did everybody do L'Hopital's rule, okay?
Yes.
Well, I could, but it went wrong somewhere.
The poopy towel.
Okay, limit as x approaches -1, g of x minus 2, all of 3x plus 1 quantity squared. Now, what is g of x?
Y.
Where's g of x?
It's Y. Y equals G of X.
Y equals oh, it's the solution to this equation. G of -1 is equal to 2. So, what happens when you plug in -1 there? You get 2 minus 2, here. 2 minus 2 all over 0. 0 over 0, it's indeterminate. I can use L'Hopital's rule. So, L'Hopital's rule says, G, take the derivative of the top. You didn't use the Cauchy rule, did you?
No,
Okay. Weren't you the person that did that though?
That's Anya. That's Anya.
no,
What was
no,
that? Who's on you? And then you take the derivative of the bottom, 6x plus 1.
Video, you know.
Oh. Oh, that was stupid.
What did you do?
I put the 2 in the numerator.
Huh?
Don't know why.
Oh, I
What 2?
Because
the
the
square.
squared,
You know how you move it down? He put it in the numerator.
So I had 2/3, like,
Because he thought it was like taking the entire derivative.
But the 3 is in the numerator.
What?
That makes no sense.
I see it now.
Oh, so the problem was 2 times 3 is 6.
Yeah.
No,
I
you know, he
guess.
thought it was.
Wait,
What is this? Let y equals g of x be the particular solution to the given differential equation. What is a solution to a differential equation?
So like for example, if you have a differential equation dy dx equal 4y, the solution is y equal y naught e to the 4x. This is called
You
the
have to
solution.
find the y.
In other words, they give you the derivative, the solution is what was the original function. That's what a solution is. What was the original function? Voila.
Is that not a -6 in the bottom of the L
No, because you're finding the derivative of the top and the derivative of the bottom.
Wait, why would there be a -6 there?
No, I was thinking the derivative.
Because he thinks x plus 1
No, no.
squared
He's
is
having
x
problems
plus
with
1
L'Hopital.
divided 2.
Yeah.
Oh my god. Wait, this is BC, right?
No, I did it right in my phone.
Okay, we're going on to number 5. Okay, you gotta tell me what we had problems with.
Number B.
Everything?
Number B.
Okay, I'm just gonna tell you, 5A. They're not even trying to trick you. They want you to find the average value.
Wait, Mr. Park.
1.
Mr.
Oh
Park.
wait, B
Joe wants
minus
to
A. Integral from A to B of the.
Mr. Park.
Wait, I mean,
Oh my.
yeah.
Cho wants us to do 4D.
Use Euler's method?
I don't know what I did wrong.
Here, wait, second.
Okay, look at this. We only got 4 minutes left. I thought we were gonna finish early today. Okay, that's not happening.
Yeah,
Okay, can you compute it? You're hungry?
You had a food.
Can I trust that you can compute this without a calculator?
Yes.
Are you sure?
You did it.
Find the volume? Are you kidding me?
Yeah, I got something
Okay,
wrong.
here's the fun of it. So if I make a rectangle of infinitesimal width and revolve it around, see, this is where you gotta think about it though. Hey, you want this,
What's negative?
right? So what's the formula for this? Pi times the radius squared, in this case is dh, yeah? Okay, and then what is the radius? It's 1/20th, 3 plus h squared, and you add it up from 0 to 10.
Oh, I took the.
Now, the only way you can integrate this is you gotta actually multiply this out.
Oh, jeez.
What did you do? Were you, I
I took the.
don't tell me, Davis, don't tell me, oh, just make the power 1 bigger, put the 1/3 in the front, and since the derivative of the box is 2h, just divide by 2.
No, it wasn't, oh, okay, it might be just as bad as that, but basically I just split into terms, I made the 3 plus h squared into 3 squared plus h squared. And then I took that.
Oh, so you went a plus b squared is a squared plus b squared. Davis, you never
Yeah.
did stuff like this before.
I did that.
You never did stuff.
Okay, see? And don't, I don't know if this is A, B, or BC, but some people are trying to simplify. Look, once you compute the antiderivative and you plug in the top number, bottom number, subtract, just leave it. Don't simplify anything. Kong, I think you're going too far.
What?
You don't have to show off arithmetic, you know. Just like Takata. He wants to show off that he was like math class champion or something.
Gotta.
What?
Just don't simplify your answers. No, because some of you
Okay, let's keep going.
Just write it in blood.
Okay, and then finally, r equals 1/20th, 3 plus, come on! This is a related rates problem. All you have to do, what are the 3 steps to do a related rates problem? Write the equation, but they gave you the equation. Second step, take the derivative with respect to time. R dot is equal to, throw the constant on the side, the derivative of 3 is 0, and the derivative of h squared is 2h times h dot. Now they're asking you to compute h dot, so all you have to do is plug in numbers for h and r dot, but these were given. What was h? 3, and what is r dot? -1/5, and then I trust you guys can solve for h dot, yeah? A lot of people did not put -1/5, so they got -1, because it says it's decreasing. Okay, we got 1 minute, we're in trouble. Okay, you know what, I don't wanna rush through this, we're gonna do this tomorrow.
Okay.
So tonight's homework is to finish part A.
Are you ever here after Mr. Park?
Oh,
Are you ever here after school?
yeah, I'm gonna be here after school until 3:42.
Mr. Park, will you record tomorrow for me? Oh,
Yes, because
me
then
too.
we're gonna, yes, because we're gonna go over that multiple
I'm
choice
gonna
part.
be out of school the rest of the week.
That's the delta X.
I'm gonna be gone.
Oh!
All right, just leave it on your desk, I'll come around. No, you guys are keeping this. You guys are keeping this.
Mark,
Yeah.
on
lunch.
Thursday. Do we have class?
Hi, Mr.
Yeah,
Park.
bye. Yes.
In the morning.
Well,
So I have a test in the morning.
oh, that's fine, but just keep up.
I want to keep up. I don't know what the cutoff was for.
Wait,
class.
Wait,
That goes to 3 or 5.
What are you doing?